Hi, I'm Guang, 50 years old. In this lesson on limits calculation, we're taking a look at the example we have here. Well, for this example, what we need to do is to show that 8 over 7 multiplied by 8 over 9 multiplied by 16 over 15 multiplied by 16 over 17 and so on is equal to pi over 4 square root 2 minus square root 2. Right, so what exactly is this kind of example? And you might even be wondering, how is it considered as limits, alright? So, of course, there are some things that you can change when you first see this question. So normally for these kinds of questions, what you want to first find is a kind of a pattern. So, can you find any patterns in this part yet? So one thing very obvious that you might realize is 8, 16, 24. So each of them repeats 2 times, and of course they're all just multiples of 8. They're increasing multiples of 8, alright? So what happens in the denominator? Well, in the denominator, since you do have 2 copies of each of these numbers, the first denominator you see will be the number minus 1, while the second denominator, that will be plus 1. Right, so now that we've known what kind of a pattern this is, so now it is that we somehow write it into an expression, alright? So for these things where you have a lot of them multiplied together, you would generally like to use the pi notation, right? So pi notation, let's say our n starts from 1 and ends at, so at this stage there are 2 ways you can use to represent whatever we have up here. So one way, of course, is to directly put until infinity, while the other will be to put it as some kind of a variable that you make. And of course, if you want to put this as the variable, in front you need to have limit, and that variable approaches to infinity, alright? So those are just 2 ways you can choose to write your pi notation. Alright, so now that we know a pi notation, so expressing this, we have here 8n divided by 8n minus 1 multiplied by 8n divided by 8n plus 1. Alright, so this will be a kind of form you will see. So next we can divide both numerator and denominator by 8 for each of these fractions, or you could also say divide by 64 in both numerator and denominator if you combine the 2 fractions. So you have pi notation. N is from 1 to infinity, and you have n divided by n minus 1 over 8. And then here it is multiplied by n divided by n plus 1 over 8. So once again here, it depends on what kind of method you have learned. Sometimes you might just see from this step you can immediately get some kind of a gamma function form, but sometimes you will see it's continue to go into n is equal to 0. So if n you want to start from 0, but your first term then is 1, what happens? So if it starts from 0, then you just have to make it n plus 1. And then this is divided by n plus 7 over 8. And this is multiplied by n plus 1 divided by n plus 9 over 8. Okay, so at this step, what you might apply is something called a Wallace product. But of course, before applying the Wallace product to whatever question you have, you always need to check. This is n plus 1, this is n plus 1. So 1 plus 1 is 2, and in the denominator you have 7 over 8 plus 9 over 8, which also gives 2, which is right, since both in the numerator and denominator, if you add them up, that'll be 2. Alright, so since both of them are 2, we can use the Wallace product here. So what happens in the Wallace product? What you'll see is gamma 7 over 8 gamma 9 over 8 divided by gamma 1 gamma 1. So just now I said that sometimes they just stop at this step and immediately get a gamma form, right? So what you might realize is that they will just have, like in the numerator, let's say it is just n, which is technically a plus 0, so then you'll just add on another 1, alright? Or you could just change it into this form and have that form of a product of gamma functions. Right, so what is gamma 1? Gamma 1 is just 1, so the denominator will just be a 1. But in the numerator, we can't exactly solve that just yet, since we have gamma 7 over 8 multiplied by gamma 9 over 8. And we don't really have any information on what these gamma values are. So you might not be able to solve them individually, but if you put it together, you will be able to solve it. Well, exactly how, you might wonder. So what you might use here in the numerator first, since you do have gamma 7 over 8 and a gamma 9 over 8. So how about let's change up the 9 over 8 a little bit to get 1 over 8 multiplied by gamma 1 over 8. So for this, some of you might know it as some kind of a functional equation or whatever you might be taught, alright? So what happens here essentially is, in order to find the value of a gamma, you have that kind of integration. Or you could also express it in a factorial form. So since gamma n is equal to n minus 1 factorial, well then technically you could bring out a n minus 1 to make gamma n minus 1. Since this inside, once you bring out the n minus 1, you'll be left with n minus 2 factorial. So when you change it back into a gamma form, you have a gamma n minus 1, which is kind of just what we used over here. Alright, so why exactly do we need to use this at this step here? So at this stage here, since we aren't able to solve that just yet, once we change it into here, we will need to use another formula, as you might call it. So 1 over 8 stays on the outside. Now this time the formula you use is called the Euler reflection formula. Right, so how does this work? Now what you might see is, let's say you have gamma A. Gamma A multiplied by gamma 1 minus A. Alright, so this will give you pi divided by sine A pi, or sine pi A, however you like to write it. Alright, so this is the Euler reflection formula, which is what we are going to use over here, since if you realize 1 over 8 plus 7 over 8 is just 1. So this is going to give us pi divided by sine pi over 8. Right, so now that we have changed it into a trigonometric form, how are we going to continue? Since sine pi over 8, we technically do not know immediately what kind of value it is. So in this case, you have to continue with a half angle formula or double angle formula, depends on which approach you take. So 1 over 8, and then you have pi over. So the half angle formula, well, there will of course be this square root, then inside it is 1 minus. So you have a cosine 2 times this angle, which is cosine pi over 4. And cosine pi over 4, you could just write it first, or you could also immediately already change that into a square root 2 over 2. Alright, so this is what you are seeing. 1 over 8 multiplied by pi divided by square root 1 minus square root 2 over 2, and then divided by 2. Okay, so the next step, what you can obviously do is like common denominators and then bring the 2's out. So since once you common denominator, you will have 2 copies of these 2, they'll just come out as a 2. And then you have square root 2 minus square root 2. So then you just combine the 2 fractions and you'll see pi divided by 4 square root 2 minus square root 2. Right? So this is what is given in the question, since we have to show that it is this solution. Alright? So for these kinds of questions, they're pretty interesting if you might find them, since you start off with every single number as rational numbers. But then once you have infinite of these rational numbers, they just become an irrational number since you have these pi. Alright? So of course then, for all of these numbers, depending on the question, there's always different variations. Maybe you have a lot of rational numbers and they still come out as a rational number. Maybe you have irrational numbers and they come out as rational or irrational. It really depends on the kind of question that you see. Alright? So once again, let's take a look at all the methods we have used in this example. So firstly, we try to get a pi notation for the original question, then simplified it a bit, well, made a little bit of modification, used the Wallace product, change it into a gamma function form, and then use a property of the gamma functions to once again modify a little bit, then use a Euler's reflection formula. So after Euler's reflection formula, you just use double angle formula, then at last get your solution. Alright, so I hope for this lesson you can understand everything here so far. I will be ending this lesson here, and thank you for your watching.